All right, so let's go ahead and start drawing some Lewis structures. So here's some steps for some relatively simple Lewis structures, and then later on we'll go into the more complex ones. But the main thing that you want to do here is practice. There's a lot of this stuff, a lot of nuances that kind of just come out best with practice. So on the left, I'll have the steps, and then I'll do some examples over here. Oh my God, good enough. So we'll do CO2, C2H4, and hydroxide, so OH minus. So we'll draw the Lewis structures of those. So the first thing you want to do is you want to count the total valence electrons. And remember that if you have charges, if you have a positive charge, you lost an electron, so you have to subtract out an electron. And then if you have a negative charge, you gain an electron, and so you have to add an electron. So let's take a look at CO2 first. So we've got C and we've got O. If we take a look at our periodic table, carbon has 4 valence electrons. There's only 1 of them. And then oxygen has 6 valence electrons, and there's 2 of them. So that's 6 valence electrons times 2. And then when we add both of these up, we'll get 16 valence electrons. Here, each carbon has 2 valence electrons. We've got 2 of them. Hydrogen, each hydrogen has 1 valence electron. We've got 4 of them for a total of 12 valence electrons. And then hydroxide, oxygen has 6 valence electrons. Hydrogen has 1, and then the negative charge is 1 more for a total of 8 valence electrons. So that's step 1, counting the valence electrons. Overall, pretty simple. Step 2 is to draw the skeletal structure. But the key thing to do here is to do it correctly. So some rules to help you do this correctly. Hydrogen is always terminal. Terminal means that it's on the end. So hydrogen will never be in the middle of a molecule, only forms 1 bond. And then you put the less electronegative atom in the center. And the last tip for you is that OH is a common motif. So let's go ahead and check that out for each one of ours. We've got CO2. If we think about a periodic table, top right is more electronegative. Oxygen is more closer to the top right than carbon. So oxygen is the more electronegative. We want to put the less electronegative in the center. So you just want to put carbon kind of in the center, and then oxygen's kind of around it. In general, stick with kind of normal molecules. Don't try to make like squares or circles or stuff like that. Keep it pretty normal. This next one is C2H4. So hydrogen is always terminal. So hydrogen's got to go on the end. And then you have 2 C's. And so this is where it just kind of comes down to practice. Generally, when you have 2 of the same element, something like this, you're going to want to place them right next to each other. And then since you've got 4 hydrogens left, just kind of put 2 on each side. Something like that. And again, this just kind of comes through with practice, seeing some correct answers and trying again and again. And OH, there's not a terminal atom. There's only an O and an H, so that just gets drawn like that. So after you've drawn the skeletal structure correctly, the third step is to add bonds and lone pairs. So in the first step, you want to start with 1 bond from central to terminal atoms. And central to central as well. Basically, you just want to give everything 1 bond and then go from there. So something like this, OCO, we have O, we have CO. So we'll just draw a bond here, bond here. If we think about it, we originally had 16 valence electrons. We just used up 4 of them, 2 per bond, so now we're down to 12 valence electrons there. This next structure, just basically want to give everything about 1 bond. So there we go. Originally we had 12 valence electrons. We created 5 bonds. That's 10 electrons. So that means there's only 2 valence electrons left. And then we've got OH. We originally just draw a bond there. We originally had 8 valence electrons. Used up 2 of them to form this bond. And so there's 6 valence electrons left. The next step is to give lone pairs, to give octets. Remember, everything wants a filled valence shell, so our central atoms want filled octets. The exception here, of course, is hydrogen. It only wants a duet. And then you want to start with the most electronegative atom. So in this first one, we've got oxygen and carbon. Oops, there should be an oxygen. If we look at our periodic table, oxygen is the more electronegative, and so it's gonna get some lone pairs until it's filled with an octet. So this oxygen, we give it 6 electrons, and it's got 2 electrons from the bond, so it's got an octet, and then we've got 6 more, so we can put those other 6 right there. And now we've used up all of our electrons. This one, we've only got 2 electrons. If we look at our structure, both carbons are missing a filled octet, right? They only have 6 valence electrons. So you can just arbitrarily pick one of them to give the electrons to, and then used up all of them, so you can't give them anymore. And then here we've got 6 valence electrons left. Oxygen needs 6 more, so we'll just fill that up. And now both this oxygen and hydrogen are happy. The oxygen's got an octet, the hydrogen's got a duet. But if you look at our first 2 structures, our carbons don't have octets. So let's see how we're going to correct that. So in step 4, we're going to move electrons to make atoms, we're going to say happy. We'll see what this kind of means more in depth later on, but for now we're going to follow the octet rule. So everything's going to want 8 valence electrons, so we want to give octets / full valence shells. So hydrogen only wants 2. So let's redraw our pictures that we had above. And then look for things that don't have an octet. This carbon right here doesn't have an octet. So let's move one of the lone pairs into a bond. And if we do that, if we think about then carbon will have 3 bonds. That's only 6 electrons. That's still not an octet. So we need to move one more lone pair. So I'm going to move it from this other oxygen, which is the correct decision. Later on, we'll learn why not to pull it from this oxygen. So when I go ahead and do that, now I have a double bond here and a double bond here. Think about those lone pairs went into the bond, so they're no longer on the oxygen. And so my molecule looks something like that. And so all of the elements here have a filled octet, both of the oxygens and the carbon. On this other one, I had this lone pair on this carbon. This carbon does not have a filled octet. The one on the left does. And so we can move this lone pair into a bond. And then when I do that, both of my carbons have an octet and the hydrogen has a duet, so it's happy. And if I think about here, this oxygen has these 6 electrons and then it has 2 in the bond, that's 8, so that's happy like that. And then the hydrogen has 2 from the bond, and so it's happy like that. So this one we can actually leave as it is. And then the only thing we have to do for this one is we have to realize that hydroxide has a negative charge, and so we have to indicate that. And so for right now, what we're going to do is just put brackets around this molecule and put a negative charge there. Later on, we'll learn where the negative charge goes. So those are the simple steps, nothing really breaking too many crazy rules here. And again, really what you want to do is practice. So I'm going to draw some or write some molecule structures here: water, methane, ethane. All right, so here's some formula. Go ahead, pause the video and draw the Lewis structures for them. All right, so hopefully you pause the video. Here's kind of the answers. But again, you really want to be able to do this on your own. Triple bond there. Cool. And so just some kind of things to think about. Remember, everything wants an octet. And so think about halogens generally form one bond. Oxygens or chalcogens generally form two. Pnictogens generally three. And then carbon over here generally four bonds. So just something else to kind of keep an eye on.